we can use our full formalism we developed in the previous slide. Let's see, the previous slides. There we go. All this stuff. I have yeah. We can use all this stuff to handle this problem coming up. Okay, so we break down the radius vector into its components. 3 cosine 30 degrees in the x direction, 3 sine 30 degrees in the y. Force is 5 kilonewtons cosine 45 in the x, and 5 kilonewtons negative sine 45 in the y, because it's pointing down. Let's go to my Excel spreadsheet. I've already put all those things in. The radius being, what was it? I forgot. 3 meters. 3 meters, and that would be at 30 degrees. 3 meters cosine 30, 3 meters sine 30. 5 kilonewtons cosine 45, negative 5 kilonewtons sine 45, and calculates the moments. And this stuff here don't even need, because it was from the previous problem. Okay. And you could get the unit vector and all that stuff too, but that's not what we're looking for. And this in the book gives you the identical answer: 14.5 kilonewton meters clockwise, negative. Did we get negative in the Excel spreadsheet? We got negative in the Excel spreadsheet. Okay. Yeah, same thing. And of course, these are a couple other ways to look at the solution. You'll notice, let's go back. Here we go. We could simplify this. This is dx times fy. We only have to worry about the perpendicular distance. We've got two forces. We've broken down this one force into two. So we've got fy times dx, giving us a negative moment because it's clockwise. Fx times dy, negative moment because it's clockwise. So we can look at it that way, which is solution 2. Same answer. Solution 3 looks at it from, we're rotating the axis, the coordinate axis. We're letting the x direction be along this and the y direction being this way. So now, with our redefined axis, with our rotated axis, we just have 3 meters in the x direction, and we only have to worry about this component, 5 kilonewtons times sine of 75. And guess what? Same answer. Okay, two forces now. Let's take a look at that guy. And we'll go to our Excel spreadsheet. Okay, picking this up and taking a look at our Excel spreadsheet. There we go. ROA 050, F1 negative 60, 40, 20. This is the beauty of the Excel spreadsheet, is that you've got all the formulas set up so you can just look at a new problem and just rock and roll with it. Radius from O to B, 4, 5, negative 2. F2, 80, 40, negative 30. M2, negative 70, negative 40, negative 240. Oh yeah, that's the m's. Okay, and then the sum of the m's, which is just the sum of these. Each component is the sum of these two. There we go. Sum of these two. Now, you'll notice the angles come along for the ride over here. Let's go back to the problem. And it goes through all the calculations and all the numbers and everything, which is why I like an Excel spreadsheet. You set it up, and this number crunching, the tedious math becomes automatic. And you get 30, negative 40, 60, just like the spreadsheet, and the angles, just like the spreadsheet. Okay. Less calculations by hand. Okay, now, a theorem. And this is just from the distributive property. These forces are bunches of sums of forces. Well, you can distribute it. You can add up all the forces. If R is the same, just add up all the forces. F1 plus F2, say sum of all the forces. As long as all the forces have a line of action through a common point. So you're looking at the moment about O, you got to take R to that common point. Actually, you could take R to any point along the line of action of the resultant force. Resultant, that's the key word, along the blue line. Okay. So this is a problem you can resolve X and Y. Now you want it around point O. You can take the two forces, just like we looked at earlier. You can take the two forces, split them up, and O can be from, you can look at this one times this radius plus this one times this radius. 400 sine 30 times 2/10 of a meter. You got that answer. 400 times 30 times 4/10 of cosine 30. 400 cosine 30. 3/10 of a meter negative to get this answer. So that's pretty easy, what we've seen before. Now we have this is actually calculating the moment separately. Uh, 400 sine 30 times 2/10 of a meter in the positive. 400 cosine 30 times 4/10 negative. Negative 98.6. This is the sum of the forces. Now you could always just separate. You could take the two forces times R, or you can take the R times F. Sometimes you want to use Varignon's theorem in reverse. You have this problem. This is a lot easier, or excuse me, this is a lot easier. I like this one best, actually, because it's just this force times this distance minus this force times this distance. This isn't too bad. Still, yeah, anyway. And then this is the, doing all the vectors. This is automatic in Excel, which is what I've been showing you pretty much. But if you don't have Excel handy, you might like this better. You can go in reverse. You can do it any of these three ways just fine. Whatever's handiest. If you only have a calculator, maybe that one's handiest. Okay, let's talk about moment around a particular axis, which I talked about at the very beginning of our lecture and looked at a door. A door can only swing, only a moment along the axis of the hinges will allow the door to move. Any other moment about an axis perpendicular to the axis of the hinges will have a reaction moment, an equal and opposite reaction moment. So we're interested a lot of times in the moment that is directed along a particular axis that will actually cause something to move. That's what comes next, and we'll pick it up in the next video.